Hi folks, Mr. Long here. Now we're going to do some examples on getting the derivatives of arcsine, which is sine inverse, or cos inverse, which can be called arccos, tan inverse, which can be called arctan. So the process is very similar, so we really need to understand what things represent. So remember that arcsine is tan inverse, so that's a ratio. So that means that this whole thing is considered to be angle y. So what does this mean? So with these, I draw the triangle every time. Some people memorize the formulas, um, and you can memorize those formulas if you want and do the chain rule, or I'm going to show you an approach that I think requires a lot less memorizing. You can see, so we draw a right angle triangle. That doesn't take long. Sine is opposite over hypotenuse, so that means this side is x squared, this side is 1. And then by Pythagorean theorem, we know that this side here is going to be the square root of 1 squared minus x squared, right? Be careful with that. So that equals the square root of 1 minus x to the fourth. Okay, and I should probably label each of those sides. Hypotenuse, opposite, and that's our adjacent. Okay, so now what do I do? Well, I know I write out that sine of y, right? Sine of angle y equals x squared. Okay, it's x squared over 1. That's what we know. Sine, because sine here, it means that I'm doing opposite divided by hypotenuse. So now I differentiate. Y prime multiplied by cos of y equals 2x. Divide both sides by cos y. Y prime equals 2x over cos of y. What does cos of y equal? Cos of y equals adjacent divided by hypotenuse. Adjacent divided by hypotenuse. So 2x over cos of y, and cos of y is worth that divided by 1. So square root of 1 minus x to the fourth. And that, folks, is your derivative. Okay, process is the same every single time. Okay, every single time. So again, triangle. Start with angle y there. We're dealing with sine. The ratio is root x, so opposite is root x, and 1 here. What does that make the adjacent? The adjacent is going to be the square root of 1 squared minus root x squared. What does that work out to? 1 minus x. Okay, and that's our adjacent. There's your hypotenuse, and there's your opposite. Okay, so let's write this down then. So we're dealing with sine. So sine of angle y equals root x. I now need to differentiate both sides with respect to y. So I write y prime multiplied by cos y, and that equals the derivative of root x is 1 over 2 root x, hopefully from memory. Divide both sides by cos y. Y prime equals 1 over 2 root x times by cos y. Well, what's cos y worth? Cos y is worth that right there divided by 1 because it's adjacent divided by 1. Okay, adjacent divided by 1. So y prime ends up equaling 1 over 2 root x multiplied by the square root of 1 minus x. Okay, and that is your derivative. Now again, there is a whole other way to do these, but it involves memorizing all the formulas and using the chain rule. This way I find to be much simpler. But again, if you wanted to, you certainly could do that. You certainly could do that. So now we're going to do the same thing, but this time we're going to do it with cosine. Okay, we're going to do it with cosine. And again, start by drawing your triangle. It's the best way to start all of these. So that's your angle y, right angle triangle. We're dealing with cosine. So cosine is opposite over hypotenuse. And so we know that the opposite, and this is, yeah, so what you have to do is, or sorry, adjacent over hypotenuse. This is tricky. If you've got a fraction there, you need to let that be the side. So this is actually x over a, the adjacent side, because it's cos. And then we're going to make this side 1. And we should write down that that's the hypotenuse. That is this right here is the adjacent and opposite. So what will the opposite be? The opposite squared would be 1 squared minus x over a squared, right? Which is x squared over a squared. A is just some constant. So the opposite equals the square root of 1 minus x squared over a squared. So yeah, and it's definitely recommended. So a lot of people, the mistake that they would make, and it would be understandable, is to make that the adjacent, to make this the hypotenuse. And I don't think that you'll get things to work out right for you. I don't think so. Certainly all the examples that I've seen are done this way. Okay, so, and we're doing cosine. So again, let's get our derivative now that we know those relationships. So I know that cosine of y equals x over a. Okay, the cosine of y is x over a. Now let's differentiate both sides. So the derivative of cos y is going to be y prime multiplied by negative sine y. And that's going to equal, you know what? X over a just equals 1 over a multiplied by x. So that's like a straight line, right? So we think of that as a fraction, but it's actually 1 over a multiplied by x. So the derivative is 1 over a. Okay, so now I need to isolate by dividing both sides by sine y. So y prime is going to equal, and the negative there, I can put the negative on the top or the bottom. The convention is that I put that negative on the top. So it's going to become negative 1 over a sine y. But folks, what is sine y worth? Go back to your triangle. Sine is opposite divided by 1. Well, what's the opposite? Opposite is that right there. Okay, the opposite is 1. So opposite divided by 1, so it's just opposite. So 1 minus x squared over a squared, all under the square root sign. So let's take a look at this. So it's just going to be negative 1 over a multiplied by the square root of 1 minus x squared over a squared. Okay, and that's your derivative. All right, let's do one with the product rule. So this is the derivative of x multiplied by arc cos 2x. And you know, it probably is good if we had a bracket around there. So this is going to be a, this is going to be b as we go through this. So I'm going to let a equal x, a prime then is 1. B is going to require more work because we know that the arc cos derivatives are a little more challenging. So let's do the B part over here. Start with a right angle triangle. Draw that, and then our angle is y. And so we know that that's 2x over 1. So if cos is 2x over 1, that's adjacent. So 2x goes here, 1 goes here, and what will this side be? The opposite side? The opposite side is going to be the square root of 1 minus 2x squared, right? 1 squared minus 2x squared with Pythagorean theorem. So that's going to equal the square root of 1 minus 4x squared. Okay, and that's your opposite side. So we have opposite, hypotenuse, and adjacent. And so now let's go through this. So we know that the cos of angle y equals 2x, right? That's the ratio, 2x divided by 1. And let's do the derivative of that. So the derivative of the left side is y prime multiplied by negative sine y, and that's going to equal the derivative of 2x, which is just 2. Isolate for y prime, and y prime equals negative 2 divided by sine y, right? Because that negative there can go on the top or the bottom. And by convention, again, we put it in the numerator. So now I need to do, so that, by the way, is, that y prime is actually our b prime. And our b, we know, is, all right, b was just arc cos, oops, 3 C's, arc cos 2x. So the formula for the product rule is a prime b plus ab prime. So a prime is 1. We don't need to worry about that. B is arc cos 2x. So the derivative is going to be arc cos 2x. And then it's going to be, oh, I didn't finish off that derivative, did I? Sorry, folks. What did I need to write there? Negative 2 over sine y. That becomes, because I can't have my derivative written in terms of y, negative 2 over sine of y. What's the sine of y? Sine of y is opposite divided by hypotenuse. And what was the opposite? 1 minus 4x squared. Square root of. Okay? Sorry about that, folks. So I'm just going to go back over this now. So that's our a and our a prime. This is our b and our b prime, right? That's your b prime right there. Okay, so, and this is b. So now we've got a prime b, and now I have to do a times b prime. Well, what's a worth? That's x. So I've got x. X is being multiplied by this, okay? Those two things are being multiplied. So remember, we have negative 2 times x is going to become the numerator. Negative 2 times x is the numerator, all divided by square root of 1 minus 4x squared. And that, folks, is your derivative with the product rule, okay, with arc cos. All right, we have one more set of examples to do, and that's with tan. Okay, one more pair of examples. Here we go. So our first example is d by dx of arctan ax squared. A is just, again, some constant, coefficient. So let's go through this. So we're dealing with tan. Draw our triangle. Angle y here. And then tan is opposite divided by adjacent. So the opposite is ax squared. The adjacent is 1. And then the hypotenuse squared would equal 1 squared plus ax squared squared, right? That's Pythagorean theorem. We're adding the squares of the two sides. That works out to 1 plus a squared x to the 4th. That's the hypotenuse squared. So the hypotenuse is then the square root of 1 plus a squared x to the 4th. Okay, so we have that. Now let's go ahead and do our derivative. Tan of y is worth ax squared, right? Because ax squared over 1 is the ratio. So tan of y is ax squared. Let's differentiate both sides. So we know that the derivative of tan y is sec squared y, which is 1 over cos squared y. So the derivative of tan y is actually y prime over cos squared y. And that equals 2ax. The derivative of x squared is 2x, so 2ax. Now I multiply both sides by cos squared y. Y prime equals 2ax multiplied by cos squared y. Well, what's cos squared worth? Cos squared is worth adjacent here divided by hypotenuse here. Okay, adjacent divided by hypotenuse. So y prime equals 2ax multiplied by the cosine squared. What's the cosine? 1 over the hypotenuse, which is 1 plus a squared x to the 4th, square root of. So now what I need to do is square the 1 and square the numerator, square the denominator. So I'm going to end up with 2ax divided by 1 plus a squared x to the 4th. And that's your derivative. I know these are challenging, folks. I know they're challenging. And I'm going through them fairly fast because I know sometimes that my videos are way too long. But that's the derivative right there. Okay. And you know, these don't come up very often, and that's why I encourage you to, like, again, instead of memorizing all the formulas, it's just a lot easier to work with the triangles. Because if you look at the start of your triangle, it's the same thing every time. And then now you read that it's tan. Tan is opposite divided by adjacent. Well, the opposite is there, so the opposite is 2 over x. The adjacent is 1. And then our hypotenuse squared is going to equal 1 squared plus 2 over x squared, right? Adding the squares, which is going to work out to 1 plus 4 over x squared. And then the hypotenuse, and actually, if we remember, when we're doing the derivative of tan, arctan, we always end up squaring. It's always, because the derivative of tan is sec squared or 1 over cos squared, so we're always squaring that hypotenuse, so we don't have to worry about getting the square root, right? So we can just stop there. So I know what the hypotenuse squared is, because that's what I'm going to need, is a square of the hypotenuse. So now let's do the derivative. So I'm working with tan. Tangent of angle y equals 2 over, let's rewrite that properly, 2x to the negative 1, right? So we can apply the power rule. So now the derivative of tan y is y prime divided by cos squared y, or multiplied by sec squared, but it's a lot easier to divide by cos squared y. And that's now going to equal negative 2x to the negative 2, right? So we multiplied the negative 1 by 2 and reduced the exponent by 1. Okay, let's move that to there. Now what do I need to do? Well, I need to multiply both sides by cos squared y. Y prime will equal negative 2 cos squared y, but I'm going to write that x to the negative 2 in the correct place, which is in the bottom. Okay. Now what I need to do is figure out what that is worth. What is cos squared of y worth? Well, we know over here that cos is adjacent over hypotenuse. What's the adjacent worth? The adjacent is worth 1. The hypotenuse is worth, or the hypotenuse squared is that. So the hypotenuse would be the square root of 1 plus 4 over x squared. But look at this. We have to, oh, sorry, that should have been, yeah, cos, so I have to get cos squared, which means I have to square the square root of that. So I end up with 1 plus 4 over x squared. So that's going to end up being negative 2 over x squared, and then it's, let's see here, do this properly, I'll just multiplied by cos squared. And cos squared is 1 over 1 plus 4 over x squared, okay, which ends up equaling negative 2 times 1 is negative 2 over x squared, and then in brackets 1 plus 4 over x squared. Okay, folks, so that is that's your derivative for this question. Okay, so process every time is the same. Draw your triangle, differentiate implicitly, which means differentiate with y inside the angle, and then after that, replace your sine, cos, or tan of y with values of x that are related to the triangle. Okay, process is the same every time. All right, I hope that helped. And now you'll be able to go ahead and try some of these questions.